How's it going, everyone? Welcome. Elder Gonzalez here. And let's take a look now at this thing called the effects, particularly the use effect. And why do we even need to have that on our React application? Just to make a quick recap of how do I get here, right? Is by looking a little bit of history of the problem that Facebook has back then in 2011 when on the traditional web development, when you have the model, controller, and view, right? So the model is where you hold the piece of data. But if this piece of data now need to be shared across different layers, aka different model, view, and controllers, so what happens is that you need to update across all of these different models. But it turns out that the R&D at Facebook develops this thing called React that is saying, no. Instead, we're going to do now is hold that particular state, right? And uh, anytime that you want to update that state, it will sync those view that have access to that state or that make use of that state. And this idea was powerful because not only is something that allows us to build more complex UI elements or more rich interaction applications in a centralized way. And this is great not only for the web, but for any platform that expose a UI, and therefore you can hold this piece of information and keep it sync with the UI, which is on the mobile platforms or in the even on the web LG, right? This course is just about the web, but all of these concepts and idea and the problem that React is solved, the R&D has, is about that, right? Is that you have now this piece of information in one particular place, and any time that different user interface wants to have access to that information or make use of that, now they will sync on that. So that's great, right? And as we look at this, we first set the stepping stone of the React app by looking at what React is doing, which is creating a JavaScript object by defining is a function that allows to create is an HTML element, right? Which is pretty much what work on the other platform, the mobile and the web LG. So what you can define is this primitive, UI primitive. And on the webs are, well, sections, div, inputs, and the variants of inputs. So like type text, email, and password, or select text context area, radio buttons, checkboxes, also image, video, canvas, just to mention the most common one, all right? All these small UI units or UI primitive that I would like to call. This is something that is quite similar in the case of the JavaScript that provides now interactivity to these web applications when you have also primitive, right? Which is the basic building blocks here. In the case of JavaScript, we have primitive and objects. Primitive is, well, strings, and numbers, and big int, and undefined, null, symbols, and but the point here is that as we explore now what React is doing, what React is, and what React is doing by defining is this UI primitive in a function that React exposed to us via create elements, and what this return, which is a single object that describe is the state of that UI. Okay, and when we analyze that anatomy, which is, hey, This contains is the children's, the props, as well as the key, uh, because it can be quite tedious to always call these React functions over and over and over. It makes sense to actually, well, have at least some language that do this stuff for that avoids to write a lot of this boilerplate code. So that's why we have now GSX, which say, hey, let me now is anytime that I need to define any of this UI primitive, I do that like if I am in an HTML and combine that with JavaScript and also with CSS. This is unlike any other templated language like uh, Blade, or how do you call it? So Blade from Laravel, or Liquid from Ruby on Rails, all of this, right? So this is our specific language that have to define their own syntax in that markup, uh, because there is no way natively to do that using pure HTML. For common things like rendering a collection of elements, or conditionally rendering elements, right? So this is one of the great news, because now with GSX, uh, we can do that, right? Because this is now involved in a process, since this is not HTML, CSS, and JavaScript, something that the browser can understand, right? So it needs to some step, some process to transform or transpile from this code GSX to something that the browser can understand. So, uh, so then I look at the anatomy of this component, how you can define now these components as a JavaScript functions, where you're going to pass some props and also some children's, which is the way how you can describe is the nested content of your HTML document. So far so good, right? Because as we look at this particular way of writing UI elements, uh, now it comes with this new UI web development, or this front-end web development, where you don't have any more, when you don't write HTML, CSS, and JavaScript code, now you bundle that, all of that, in one single file. This is the component-driven development, right? Or the atomic design. So where the idea is to now, starting from a small snippet of UI primitive, and then you're starting to compose this from atoms to molecules and organisms, and then pages, and then your website, right? So that's great. In order to be as a to understand and to describe this process, but we need to need or I need to know, or perhaps, which is part of the previous exercise, is like, hey, how now this fits into entire web development? How actually can make use of this to develop web application? And it turns out that the project folder structure of a basic React application, you have now your index, you have the index HTML. When you're going to now attach, or we're gonna get a particular element, the root element, and then on the index.js or tx, you're going to now is get that element and mount that with the React applications. And because of that, then you have, this is also on the index where you define your CSS style. And then you're going to have is the entry point of your application, React application. This is when you define things like context and providers, something that is for sharing the state of the application. Remember, that's the whole point of building or using React for building UI, right? Is that you want to have this piece of information somehow, right? And all the UI that needs to, or that have access to, when that piece of state change, it will modify all of that. So this is when you define providers and all things that we're gonna see that later on in this course. But this is the home React based application, the app.js or TS. So far so good. And then you have now the models, the ES6 model, the way of how in JavaScript natively you can now wrap this file to act as a single one. All right. So here you can now is scoping things for that specific file. So in terms of understanding now how you can create your basic UI elements, all right, we also look at some convenience things like fragments, where it avoids to pollute the global or the DOM with too much nodes, right? Because at the end of the day, when you create a component, you need to return is the you need to return is the is a UI primitive, a collection of UI primitive wrapping into a patent. But sometimes you don't want that. You don't want to pollute the DOM nodes with that. So fragment is useful. And again, for the common things like rendering a list of elements or conditionally rendering elements, so we can use now is whether it is a utility called range, all right, or the built-in array function, which is is totally awesome at this point, all right. Or and from the array you now can render series of elements, because React doesn't have native ways to determine the identity of these elements. That's why you need to provide a key. So this is great because we know how to render a list of elements, right? And then what I also look at how to render conditional elements here, right? Whether it's using the if statement or the ampersand, which is the and expressions or ternary expression, and what is the subtle difference from one and another, and the edge cases as well. And last but not least is how you can now add CSS to your component and how this things works behind the scenes. Particularly the CSS model, the TLDR is that, hey, I'm going to grab the name of your component and attach some hash followed by the name or the CSS selector rule. So in that regard, I create now a unique CSS rule with a specific with a CSS specificity, right? That is a scope for that component, right? So, and then when it comes to now add interactivity to these components, it turns out to be the way we did this without React is two things. Or you attach now is an event listener to a DOM node, right? Or you now call a function on that particular UI primitive. Anytime that I say UI primitive, think of this like HTML tag, right? Pretty much, right? So, but because React doesn't do this, and the way React works is by you're passing now an event handler that is React that is gonna call your component or is gonna trigger that event or that callback function for you, right? This is known as the dependency inversion of control. This is more like a concept from the software engineering. It is quite relevant because anytime that you call your functions, this is now a library, all right? But when your functions, but when your functions are called by somebody else, which is in this case like React, so this is now is a framework, right? So you don't have control when these functions are being called. So this is pretty much like a black box, but in this case of React, you can look at when these functions are being called. Why this is important? Well, because when you want to add now interactivity, for example, like response to a button or to an event and show now something to the UI, to the user. So for example, like basic counter, okay? So the way how do you respond to that event is by defining it as a handler, right? And attach that to this event handler, which in the case of React or GSX template, you can do that is by accessing to the on and the name of the event handler, right? So this is great, right? This is great. Let me see, for example, here, right? On ended, for example. So hey, I'm accessing to that because each one of those specific elements here, at the end of the day, they are now React elements. They are transpiled to these React functions, right? And the same for here. All of this so React now adds some specific properties in exactly. So React adds some specific properties anytime that your function are called. For example, like the handler functions. So this is why when you receive that event, which is known as the React synthetic event, React what it does is to just add a nice little wrappers of some of the convenient things that we might use when we detect an event, right? So, but in order to actually now is respond to that event and then somehow store that piece of information, with JavaScript, we have a thing called scope closures. So closures is a way of how you can remember the reference. This is exclusively for functions. The reference of an identifier or a variable that live outside of the function scope, and remember that even that function is being called in a different scope where the variable was declared. So why this is important? Well, because as we look at how can we provide this place to provide interactivity and remember some piece of information, right? React provide now a particular tool called useState, which is the core loop, right? So anytime that you want to remember something, you use now a useState to keep track of that piece of information, right? And therefore, React give you is two things, the value and the setter function. So when we now set or update the value of that state via the handlers most of the time, right? So React now React now kick off this mechanism. So it involves in two scenarios. So it can happen in two scenarios. When the page is load, and there React what it's gonna do is to now is call the append.elements, and it's gonna create the DOM, the DOM, the document object model, right? Which is a tree-like data structures. And then now the page is painted by the browser. And on the scenario 2 is when the page is loaded, right? So if one of those components now trigger a state update, React will first gonna trigger, gonna detect which components trigger that, all right? Known as the triggering phase. It's going to now evaluate that function, execute that function. And if that function, or aka component, contains more components, it will continue to call that until there is no more React elements or JavaScript functions, React components, right? And remember that anytime that it calls these functions, it creates a new snapshot of the application, this JSON object that describes the current state of that UI at that moment, aka a snapshot, a new snapshot. So this snapshot, which is a information that now React have based on that trigger. This is known as the render. So it now this new version of the UI of the DOM, the virtual DOM, right? And then it's going to spot the difference and apply only the bare minimum necessary DOM updates to the real DOM, known as the commit phase, right? And when the browser detects those DOM change, it's going to now trigger a paint, and you can see now the new state of your UI. This is great. It's important to also describe that state. Why is that? Well, because now it makes sense of how this mechanism works. What is the problem that React is trying to solve, or it solve, all right? And now we can look at the nuances of this, which is, hey, how can I now update multiple states, okay? And what happened when I need to update multiple states in my component, right? This is known as batching states. So React, what it's gonna do is to update all of this UI in the next tick. You can also, and when this state updates, right, you're gonna see the new value is on the next tick, aka when the function is being called the next time. All right, and that's great, okay, because as I also explore at the difference between the rendering and the painting, especially in React, the rendering is the spotting the difference between snapshots, right? That's what a rendering is, which is not true for any computer UI application or computer graphic applications, where it say no. Render here is that I'm gonna take a raw input of data and transform into something else, right? Into an image usually. And the painting as well, as the name suggests, in the case of a browser, is, well, actually is pass through the reflow phase, or through this mechanism known as the critical rendering pass, that is going to transform is the HTML, CSS, and JavaScript into pixels on the screen. You can take a look at that at Mozilla, the MDN docs, the critical rendering pass. Quite interesting. So you can now have an idea of what this browser is doing, which is powerful and fantastic. Whoever did this, they were or the bunch of people that collaborate to make this possible is quite fantastic, because now the browser is the main window of our world, right? Jesus, that's mind bending, totally. Anyway, so yeah, good. And then, all right. So how can I work with another common cases, like rendering a form and collecting data from a form. So here is when I say, hey, okay, this is how we define is this form. the way how we now attach a data and collect the data from a form without React is by, as I mentioned before, attaching an event listener or a function call directly on that UI primitive. Okay, but in the case of React is, well, let me is, or don't let me is, yeah, in the case of React uh, is through this two-way data binding, which is a fancy way to say, hey, this is a pattern for any time that we need to update the input and collect the data from the input. Uh, and because now to do so across different input, each one of those has their own particular way. React say, no, 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 no. Let me now define is a particular interface or a pattern here to do so. And that is, well, anytime that I need to update the state, I'm gonna use now an event listener. And when I need to update or show the value, I'm going to is update the value in that input, right? Because there are some corner cases like select, like checkboxes and radio buttons. And also you want is to now provide label to this input as a way to focus your element there. This is when you can use now the label and the specific input type to actually bind that via the ID of the label and the input, right? And also provide is a name for that. This particular use case and how you can actually create your own and so on and so forth is something that is known as a two-way data binding, right? This is the TLDR of this. So once I get that, then I look at how can we now conditionally rendering elements in a list and dynamically assign is an identifier, right? So whether it is you use mat-random or ID, why we shouldn't use is an ID, especially if the arrays resize it is dimension, because we have some inconsistency in our ID. And why it's more convenience to generate if you need to have unique identifiers anytime you're rendering a list of elements. How convenient is to use the crypto.random UUID. This involved now is cryptography, okay, where it is astronomically low to have two IDs to have the same ID or to exactly. It is astronomically low to have IDs to have the same ID. To have the same ID twice. So that's great, quite convenient, quite powerful, I must admit. Okay. So yeah, so this is how you can at least do this. And when it comes to now store piece of information that are more complex like objects, how is useful or how we must always is return is a new state out of that. And there's some corner cases to do so. This is why we have like emerge.js as a way to, anytime that you have now nested objects here, you can easily update specific versions of them or a specific property and a specific level. This is why now that we are community say no, avoid any nested objects to store that piece of data. But the reality is sometimes you need to, right? And here in the engineering, you do quick things, quick and dirty, you know. So so this is how we can deal with this object state to manage this object state, and then because remember at the end of the day, React is all about to manage that particular state. Wherever you put that state, okay, that piece of information, it will impact to when or which component can access to, right? And not only that, it's gonna impact where this component will trigger is this cascade effect. So uh, because sometimes you need to have some global data that might be available across your entire applications. Now, uh, depend of your type of product that you're building, whether it's a landing page or a landing page with no client side states, right? So landing page, blogs, uh, or a heavy interacting client side application, let's say a game, right? Or some real time information that you want to keep track. For example, is some trading app, right? Uh, uh, Here is when you need to have some sort of global state. That's what we have is Redux. Okay, so Redux serve very conveniently to this purpose, right? And the other is when you build now back office applications, right? So when now the piece of state of this of the source of information, the source of truth, live now is on the server. So here, because now you don't have that piece of data locally, there are a couple problems. How do you fetch the right data at the right time? From the client perspective, the client POV, right? So how do you get the right data at the right time? How you, when you get that data, you somehow revalidate so you don't have stale data there. And avoid hammering the API anytime that you make a request by catching that data, all right? And sometimes you want is to forecast is the how the request will be resolved, okay? Which is you want to predict how the request will be resolved, right? And this is for optimistic UI. So somehow it's like when I hover here, I just want to fetch that piece of information that is going to render that. And when I click that, all right, I can now show you that. But it's now that piece of information is local. And then the other is that because that data that can be huge, how can I make it more digestible? AKA, how can I paginate that data and keep track of that state as well? So all of these are now related to network problems. It's why we have is the React query or SWC or Apollo clients that actually solve these specific problems, right? So because Redux also have these things called RTK, which if your application use now Redux, that makes a lot of sense, right? But for our cases, right, sometimes we don't want or we don't need to have that to use that RTK. But again, I just hit the brake here because I want to explain what the problem is and what are the alternative right now, which is something that you're going to get asked a lot in interview questions, especially if you are a senior developer. Right? So you understand what are the problem and you can provide is a particular solution to this, right? So far so good. Now, when it comes to look at how in the common React development we do things, which is using a component, right? And sometimes you don't want to render something, you just want to define some logic, business logic, some redirections, management, the local URL, the location of your application, or some other piece of information. So because the only tool that we have was component, that's what you see in all of these different applications out there is the component, right? So because the React team come up with a tool known as the hooks. This is what we're going to talk in today's video about, but particularly is another specific hook, right? So this is the React hooks, right? Another tool in our toolbox, which is these hooks. So hooks are now allow us to get into or hook into this React internals to do a specific stuff. So one of them is the use ID, where now React keep track of, so it have now a global registry of identifiers, and this is quite convenient for deal with forms, right? When you have forms, or you have multiple forms, and then you somehow wants to know or want to have some global identifiers. So this is one of the main use case for that. And because now these hooks have rules, right? Remember, you're hooking to React. First is this must be used in a React component unless you're using a custom hook. We're gonna see that later. Or all of this state must be at the top of those components. All of these custom hooks or hooks must be at the top of your component. The explanation again goes beyond of today's video. You're free to look and explore that in the free land of React docs. And then I look now a couple examples of how we can use now ref IDs. And when I describe the state and how useful it is, and why do we need to actually return is always a new state of our application. So anytime that you do that, what you doing or React is doing is create a new snapshot of the application. Remember, anytime that a state updates, it create a new snapshot of the application. This new snapshot we're gonna live in a different space in memory, all right? And anytime you create that, well, it's going to now create a new space in memory for that. So it is up to the garbage collector to, when there is no more reference to that object, to sweep them out, right? So why am I mentioning this? Because this is going to be useful as part of our understanding when we need to understand of the cost or the use effect. So, but in any case, another hook is the use ref. So here we can now store a piece of information that won't trigger any core loop. And so, in the use case for this is we can hold here is any primitive value in JavaScript, but what is useful is for holding is DOM updates or DOM elements, right? Why do we even care about it? Because sometimes we need these two is to interact with these elements directly. So for example, like the video or the audio, all right? We somehow wants to interact with this or trigger a specific event. So for example, like this. And what it's doing is just calling is that component here. And the idea here is to allow us to grab these particular elements, particularly audio or video or canvas, and then draw something with it, right? That's very, 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 very interesting, okay? I also look at a couple exercises to use. What is the most common use cases for that? So for example, like grab some elements and focus that. Yeah. Focus an element, or getting an element and trigger some of these elements, for example. All right. So when I look at another different hook, which is the effect, and use effect is something that might be quite hard to get your mind around it. Uh, but don't worry. So take your time, understand what is the problem, and then you're going to realize what this is all about, right? So in any case, this side effect is when you need to actually now is synchronize your React applications with some external source of truth. So for example, is hey, I do need to sync with the server state, or I do need to sync is with the local storage, or with some uh, events or global events in our application. So now things started to make a lot of sense. Uh, mm-hmm, mm-hmm. Yeah, that thing started to make a lot of sense. So, for example, making network requests. Oh, and the other is managing timeouts. It's like, hey, I do need to actually is trigger this uh, to schedule now a task that I want to complete after an X amount of time, and synchronize to what happened afterwards, right? So all of these things are managed by the use effect. And we look at the most basic example of the use effect, that it allows us to keep track the state of our information, the piece of data, right? For example, like document or title, and then update that, right? And what happened? Well, if and now deal or look at some couple exercise. All right, and these couple exercises are, hey, I do want to log in a particular value, right? Or to now is have access to the local storage. To trigger is a or for setting the theme in our application, right? I do want to store that locally. And then some of the linting rules on effects, right? So why this is important to follow them and to understand that, because not only that it will solve some of these common problems that we can have when we are dealing with React, but at the end of the day, this effect or this hook will get triggered is after every render, and it needs to if you're passing now a reactive value, or particularly if you're passing now a user state, right? It needs to keep track of what is the current snapshot to actually show that or to use that in your effect. And remember, anytime that you trigger now a new state, you are creating is a new snapshot that lives in a different location in your memory. This is the reason why it's going to annoy you if you're using now a state on this, right? And then I look at, well, how can we use now our use effects, usually for when it comes to mount or element. What is the most common using for mounting or for triggering this functions? Our mount, okay. This is part of the life cycle of your components. Whether it's you want to focus an element or to managing subscriptions, like listen for global events. So most move is one of them. Resize is another one. And what happens anytime that if you don't define is the array of dependency, or if you if you don't define your array of dependency, that component or that function in your use effect is gonna get triggered over and over and over here. And this is something that we don't want. That we want, especially when you subscribe to events. Hey, I do want is to listen. I do want to subscribe to this only once, right? So far so good, because again we look at some couple exercise like how you can resize the elements, how you can now trigger is a toasty by now interacting is with the intersection observer API, which was fantastic by the way. So when you scroll down here, you can see I changed this. That's what is showing here. Position absolute, position relative. And somehow I changed this. Because now is showing then relative none, position absolute. Oh, I do need to be explicit about when it's going to show, which is right, which is right 0, right. As you can see, it's gonna show you now here, but I also need to say, hey, right 0 and bottom 0, right? So now it's gonna render is on top of this. So I'm creating is a stacking context here. So that's why it actually show as expected. So, but in any case, this is a great thing of how you can synchronize with it. You define your functions, particularly using the intersection observer, right? And when that is done, all right, you can set this. But this is quite interesting. It's intersecting. You can also is do something like this, because now this will give us is this, right? Because this is something that will give us is when this happens, there is no need to have a if statement. It will continue to notify when that happens, and this is it, right? So this is quite great. But what happens when we need to clean up or unsubscribe to event, for example, global events? That's what we have now is this particular way of returning is a function. And this is very interesting, because if you think about this of returning is a function, right? Give me, I'll be right back. All right, and we are back. So I was talking about of this way of how you can now is clean up or you unsubscribe to global events. The way how you do this in React is using useEffect is by using now effect to synchronize with this piece of information that, or this source of truth that live now on the on, in the case of global events, on the browser, right? And here is when we use now this cleanup functions. The way how React do this using now useEffect is that you pass now a function to run this effect, right? And then and when you want to clean up, right, you now return is a function. Why this is happening in this way, right? Why is this happening in this way? Well, if you think about this, right, since you are now passing is a function, and this is something, a function that returns a function, and one of the most confusing things to me early in my career was when functions will return functions. Stuff like this will make my head spin. For example, like this. This is because you need to understand now is the language. This is now is part of the JavaScript, all right? And one of the beautiful things of JavaScript is that not only that it allows you to represent primitive values, string, number, boolean, symbols, big ints, and undefined and null, but also objects. And this object can be is like a hash map, a key value pair, or even functions. And this concept is of holding now a function, or that a function can act as a value, which you can now holding inside of a variable, and this variable will act as a container. So this function will now have some functionality described, or even some piece of data attached to that you can carry on here and there in different part of your programs. That is mind bending, bro. That is when I really understood that. It's like, what the French told these people were smoking. I don't know what the, but whatever it is like mind bending. Alonso Church, with C. Alonso Church coined that idea. Holy moly! Ch- yeah, but he coined this idea, right? The mathematical work. He's proved that the at Enschädigungs problem, which asks for a decision procedure to determine the true of arbitrary position in first order mathematical, but again, more like the lambda calculus, right? More like the lambda calculus, right? So this is now part of the lambda calculus. It's a formal system for expressing computation on functions, abstractions, and application using variable binding and substitution. There is a lot of terminology there, right? Indicate start of a function, input value, separate variable from body, and function body, right? And again, I know that this is quite dense, quite deep, but the whole point of this is that you can now, here is describing is a formal syntax, okay, or a formal way to express computation, series of statements, right? And then now hold them using a variables that you can now use across your different part of your application. So a good example of this is that if you want to now add two numbers, you just define that functions there, right? And if you want to then add a specific number or an x number to 2 or to 4 or to 5 or to any number, any fixed number, you just now get a slice of that. Again, why this is important, you might wonder. Well, because when you now want to unsubscribe to global events, for example, in this case, right? Or you want to now clean up that function. Hey, this is what I want you to do when this component get unmounted. Okay, I don't want to, let's say, or let's get rid of the local storage, for example. Or I just want to unsubscribe to global events. Or I just want to now trigger is a timeout when these things happen, right? Or when this component is mounted, I want to notify, I want to send now a network request to an analytics for X, Y, and Z, right? I mentioned this specific case because this is what the business value is, all right? So that's what I look at this. And in the last model, we talk about component systems and how conditionally rendering components will create and destroy the systems, right? How we conditionally mounted these components or create this system. If you still feel fuzzy in this concept, you can review the components instance lesson, which is something that we log here, right? In this components instance here, right? Elements don't create instance. Rendering does. So what does it mean is that when this function is called, this is when it's going to create now this instance, right? Elements don't create instance, all right? So in other words, is that you have two scenarios. When the page is loaded, now it's going to call all of these functions, and aka now creating is this instance of that, right? And when the state is updated, now it's going to recreate a new instance for that, or remove that instance. Okay, that's okay, exactly, it makes sense. Elements don't create instance, rendering does. All right, rendering does. So here in the sandbox from the video, with the cleanup function we added, is like that. So we just log here move to see, hey, I just want to know how many times we calling this, and also if we're calling this when we untoggle this. As you can see, it's not being called. So cleaning up with dependencies.
So in the examples we've been talking about recently, we have some sort of long-running process, and we want to start it the moment the component mounts, and now we've learned how to clean it up right before the component unmounts. This is what we see in this example over here, and the reason it works that way is because of this empty dependency array. We are explicitly telling React, don't rerun this code at any point between your birth and your death. But what happens if we do have dependencies, if we do want this code to rerun sometimes? How does that affect the cleanup function? To help me answer this question, I have updated our example so that now we still have a button, and that button is still intended to stop the mouse tracking, but now it all lives inside one component. So there's no more parent component that is mounting and unmounting the mouse tracker. Instead, I have this state variable is enabled, and I want to use that to start and then stop the event listener. When I was first learning about the useEffect hook, and I would run into problems like this, my intuition was that I could wrap the effect in a condition. So I could grab this isEnabled state variable, and I could say, if this value is truthy, then I want to include this effect. Otherwise, I don't. And in my mind, this made perfect sense, because it would run the effect when this condition was true, and then by removing the effect, it would run the cleanup function. Unfortunately, though, as we can see, this violates one of the rules of hooks. We are not supposed to call any hook conditionally, and this applies just as much to useEffect as it does to useState or useID. But the overall idea isn't such a bad one. So what if we move the condition to be just inside the effect, so that literally everything, the entire body of the effect, including the cleanup function, are part of this condition? Well, when I do that, I get a new lint warning. useEffect has a missing dependency is enabled. And that does kind of make sense, right? Like I'm using this state variable inside the effect, and whenever we do that, we want to make sure to list it as a dependency, so I'll do that. I'll place it in. And now, somehow, almost miraculously, our problem is solved. Like, it does track the user's mouse by default, but then you click on the button, and look at that, the numbers are frozen in time, and they stay frozen until I click it again, then tracking resumes, and I'm able to selectively start and stop the tracking process. But how is this working? Like, it doesn't really seem like we've done enough work yet. I'm suspicious by how little work was required to solve this problem. Well, why don't we walk through this one step at a time, and we'll see how this whole thing fits together. So let's suppose I refresh the page, the component mounts for the first time, we figure out we need a button and a paragraph, we put that stuff in the DOM, and then we run the effect. IsEnabled is indeed true, that's its initial value, and so we run all of this code, adding an event listener, and then we hand React the cleanup function. It's like a little present that we're handing to React, and we're telling React, open this thing at the appropriate time. Well, the user starts moving their mouse, and so we're triggering all these state updates, but the dependencies aren't changing, right? We're changing the mouse position every time the user moves their mouse, but we're not changing isEnabled, which is the only dependency, so the effect ignores all that stuff. But then, let's suppose the user clicks the button. Well, now the dependency has changed, and so it wants to rerun the effect, but it can't do that until it first invokes the cleanup function, right? We've given React a cleanup function, and it doesn't want to stack effects. Like, it always wants to clean up whatever was done before it starts a new effect. And so it opens that present, invoking the cleanup function, and we remove the event listener. So now at the moment I've clicked the button, there is no more event listener. Then we rerun the effect, except now isEnabled is false, which means all of this stuff inside the condition, which is really everything inside the effect, it skips over all that, and this effect has no real impact. As a result, we no longer have any sort of tracking, right? When I click the button, there is no more tracking, and so there's no state updates happening at all until the user clicks the button again, and then the process sort of repeats, where we rerun the effect, isEnabled is true now, and so it runs all of this code, and then we hand React the cleanup function again, telling React to call it at the appropriate time, and it will invoke that cleanup function when the user clicks the button a fourth time, because the effect wants to rerun, but we have to call the cleanup function first. Now I have a graph that should help with this. Actually, I have a series of graphs. Get ready, it's graph time. And this shows how the effects are scheduled based on what render it is. So after the first render, we run the render, and then if an effect is provided, it will run the effect, right? This is the one thing that's really true about effects, that they always run after the first render. There's no cleanup, because we haven't really done anything yet, but if a cleanup function is provided, it'll hang on to that. Then, on the next render, we run the render, and we want to run the effect, assuming one of the dependencies have changed. But before we can do this, we have to invoke the cleanup function, because we don't want to stack event listeners or whatever the subscription is. React doesn't know, but it assumes I probably don't want multiple of these things. I always want to clean up what happened last time before starting what we want to do this time. And so it runs the cleanup function, then it runs the effect, and this process repeats for every render until eventually the component is unmounted, and we call the final cleanup function to undo anything else that was still running at that moment. To visualize this another way, I have this, I guess, 3D view, kind of. These are individual snapshots, each representing a different render, and we see that after the first render, we run our effect, and then we have a cleanup function that React is hanging on to. When we re-render, assuming one of the dependencies changed, we want to run the effect again, but we have this cleanup function that we have to invoke. And it's cleanup number one, right? It's the cleanup function that was returned from this effect. I want to stop whatever is still running from this effect before I rerun the effect and potentially start something else. And so there's this nice symmetry that happens where the cleanup function is invoked before running the effect and right before the component is eventually unmounted. Now the one kind of wrinkle in this that does make it a little bit more complicated is that I don't always have to provide a cleanup function. Like, it is perfectly valid, for example, if my effect doesn't return a cleanup function, that we skip the cleanup step. And we see that in action over here, right? If isEnabled is false, I'm skipping all of this stuff, including returning a cleanup function. And so when this variable flips to false, we don't provide a cleanup function because there is no event listener. There's no subscription that we have to clean up. So it's not really like this perfectly symmetrical, but there is always the ability to provide a cleanup function. And we do want to provide one if the effect starts any sort of ongoing process, right? If we listen for events, if we start an intersection observer or a timeout or an interval, we want to make sure that we're providing a way to stop that thing so that they don't stack up. But that's essentially the idea with cleanup functions. They work really well once you get the hang of them, but it does take a while before the effect starts any sort of ongoing process, right? If we listen for events, if we start an intersection observer or a timeout or an interval, we want to make sure that we're providing a way to stop that thing so that they don't stack up. But that's essentially the idea with cleanup functions. They work really well once you get the hang of them, but it does take a while to get used to thinking in terms of dependencies. Never fear, though, we will have plenty of opportunities for practice with that.
That's a very, very interesting thing of this, because anytime you need to an ongoing process that you need to keep track of and make aware of, and make React aware of it, okay, makes a lot of sense. Okay, I need to keep track of this ongoing. If this problem is, I need to keep track of this ongoing process and make React aware of it. This is when I use now and useEffect. Not only that, but I do need is to somehow kill that process, all right, or terminate that process, because I don't want to have this long running test. I need to define is the timeline. even with this, even if I don't set this, right? Even if I don't, okay, yeah, I'm doing is this, because I do want is to run this, right? Toggle mouse tracking is this. Exactly, now it's triggering is that once. But this is quite interesting because so React say, hey, don't put conditions. Again, this is part of the recommendations, right? Don't put conditions inside of this. Yeah, don't put conditions inside of your effect. When you take a look now at the React.dev, don't put conditions inside of that. Pre-render to node stream. The rule of hooks. Hooks. Yeah, but rule of hooks component. The learn. No, is the reference rule of React. That this is an overview. Components and hooks must be pure. React call components and hooks. And the rule of hooks. Okay. For example, like this. Do not call hook inside of conditions of loop. Oh, but this is your hooks. Oh, okay, but this is for hooks. And what about, yeah. Okay. Again, hooks. It's talking about hooks, right? Or use effect. Okay. Okay. Yes, it's like how do you make that happen, you know? Okay. Not at the top level, but you can use inside of your effects. Okay. And it makes quite sense because now this function will be scheduled this function will be triggered right after the render. React is going to check the state, the value of this state, and then it's going to say, okay, I can now run this if this is true. Exactly, I can now run this if this is true. On the next re-render, is going to now recreate all of these elements, the button and the P, so on, and then right after the render happens, to call now the useEffect with the cleanup function first, right? That we provide here, and then it's when it's going to call now this, right? And because now this is false, it will never trigger this. Okay, it has its own mechanism, its own logic. Ref and cleanup function in React 19. Personally, I haven't really found a use for this. Unlike useEffect, ref callbacks can give a dependency array, which means that ref callbacks plus cleanup fire every single time. Let's say this is a very new change, and maybe I just haven't found the right use case right. But you can learn more about is here. Okay, and this is now cleanup with dependency. All right. Okay. All right. All right. Cleaning up exercise. Yes, it's quite straightforward. I know what to do in this particular case, or to react to a specific event. Okay, similar for the toasty, but in this case I need to see how you can switch off or opt out of this element. Okay, and show me the code like this. And the other is the digital clock. Interesting, because now I'm hooking into the timers here. The clock should update 1 per second, all right, and to show the current date, right? So here I'm synchronizing with this source of truth, right? And I'm setting its state here, which is gray. So here, if I define now is if I define now a state, use state here, say true initially, and I do want to hold that value here to set show timer. And set show timer, right? And I want to assign this label to this identifier, right? And when the user now click on that, no, but this is on the clock, all right? So show clock, all right, I can do that, right? Okay, so let me get rid of this, right? So what I can do is and there should not be memory leaks, no ongoing process that outlive the clock instance. So what I can say is hold a reference of this. How do I, let's say, timeout. Here, I do want to hold a reference of this, okay? And when this cleanup functions gets triggered, I do want is to now is clear the interval here, right? Which is, hey, clear interval of this reference that I have here, timeout, right? So what it's going to do here is to, hey, on the initial render, it's going to evaluate these functions and return is all of these elements here, right? It's going to run also this JavaScript code. The renders occurs, and then it's going to now schedule these functions on the initial right after the components gets mounted, right? Which is, well, now triggering is that or schedule the timer here and update the timers every second, right? So when this component is unmounted, right, it gets destroyed. So now React will going to is call this well, it's gonna call this function that I'm holding the reference here, and that'll be all. So how can I make sure that actually this will work, right? How can I make sure that this actually will work? Pretty simple. I can now is see and say console log here of the new date, right? And see what's going on anytime that it here. Of course, because this is now an object, I do can is or I can say something like, yes, let me parse this. Say JSON stringify, right? I can do something like this exactly, right? And once I click on, is now work as expected, right? And then when I click on, uh, it's now syncing that. So I don't leaving any link. So I removing all of this instance. So I clean up this. That makes a ton of sense. Stuck in the loop? While working on this exercise, you may experience an issue where the browser tab crashed. This can happen if your code contains an infinite loop. To solve this problem, you can delete the troubleshooting. Okay, exactly. Tick, and there you got it. So, but this is now something that we know. What is the yeah, this is because I know is the cleanup with dependency or the cleanup life cycle here.
So as it sits, we have this thing that claims to be a clock, but doesn't really function like one. Like, I suppose...
Or another thing that I can do here is to do something like this, you know? It's like, hey, I do want is to, instead of calling the format, which is good, I can say is, hey, I want to call is this stringify version of this, all right? And give me now the time. So show me is the time, right? And then I can is now decorate this, right? I can say it's just stringify dot now or dot time. I am not quite familiar with the date object, so date object here in JavaScript, right? The date object here. Okay, you can. Oh, okay, makes okay. To see to JSON to string to time string. Okay. To UTS string to time string to temporal instance. Limited, okay. So to string, it's gonna convert that fully to local time string or to local string, and this is the expected output. Okay, base wall availability. Okay, to local date string, but I do want is to also the date. You know, the to local string. Okay. Okay, it's using the internationalization. Okay, so I can say to local string, right? Transform this into local string, and as you can see, it's going to see that, and you're gonna get that. Pretty awesome, by the way. So there is no need to use some format and so on and so forth. This is if you want to use just this, right? So anytime what you're doing is just updating the state, updating the state, updating the state, and so on and so forth. That's a very nice things here, right? A very nice things that's happening. That's interesting that this is not getting triggered. All right. To local string. Exactly. I don't know why I didn't call that, but in any case. So I don't need to JSON stringify this. I just already have that piece of data, right? To local string. That's interesting. That's very powerful. Okay, good, good. But the thing here is that it's never calling this. Somehow it's not calling that. Hmm. Sometimes it's not calling that. Oh, okay, that's right. There you go. Of course, the function is not being called, and it's supposed to be called is after that, right? That's great and silly as well, but yet quite relevant.
For the first second, it shows me the correct time, but it very quickly grows stale, and I'd have to wait a full 24 hours before this is the correct time once more, which is obviously an unacceptable clock experience. Looking at the code, I have this time state variable which gets initialized to a new date, and then I'm using this format utility from the datefns library to format. I'm going to do this from the moment the component mounts until once every second, so once every 1000 milliseconds, and we see that this log does indeed show that it's running once per second, 2 of these intervals running, which is very much not ideal. So to fix this problem, I'm going to return a cleanup function, and I'm going to call window.clearInterval. But for this to work, I need to know which interval in particular I want to clear. So I'm going to capture that in a variable I'm going to call interval. Is what we console is blissfully remember that this is a long-running process like any other, right? It's the same structure as when we had event listeners, where we're starting some process over here and we're canceling it over here, and then there is some sort of event that happens in the interim. Before it was mouse move events or intersections. Now it's the interval firing once per second.
Alright, so that'll be all for this video. Alright, take care. Bye bye.